Okay, so we're going to continue looking at law of cosines. Some of this I'm just going to go through quick because you guys already have it in your notes. So law of sines, we learned the three types were side angle angle, angle side angle, side side angle. Law of cosines allows us to solve these two types. Side angle side, side side side. We did a side angle side yesterday, and we did part of one in the homework just a few minutes ago. Okay, so this was a side angle side problem. How do I know? Well, it can't be side 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 because I don't have a side. So if this is a law of cosines problem, it's got to be side angle side. Okay, and we did that problem yesterday in the notes. Okay, we're going to look at this one. Side side side. Okay, so with side side side, you can do anything you want in any order you want. There's no condition on what you need to find first because you know all the sides. So you can use any version of the law of cosines. Okay, so AJ, which angle do you want to find first? Well, A is a side, alpha. So we're going to find alpha. To find alpha, let's just write down what the formula looks like, then we'll plug in. If you're finding alpha, the formula starts with A. Can somebody tell me actually the rest of it? What comes after A squared?
B squared plus C squared.
Yep. Minus
2AC or BC.
2BC cosine alpha. Okay. Now fill in everything, and I'm going to square and kind of combine some things as I go. A squared. 9 squared is 81. B squared. What's 7 squared? 49. 5 squared is 25. 2 times B times C. Well, let's do this first. Let's do 2 times C, because that's easy. What's 2 times 5?
10.
10 times 7. 70. Cosine alpha. Okay. What's the next thing I can do on the right-hand side?
Combine.
Combine the what and the what?
49 and 25.
49 and 25. And that gives me 74. Okay. This is the step. You got to be careful. What do I do next? Yes, subtract 74. You cannot do 74 minus 70, and we talked about that yesterday. What's
7.
81 minus 74?
7.
7. So we get 7 equals negative 70 cosine alpha. 2 steps left.
Divide by negative 70.
We're going to divide each side by what's in front. 70 is gone. Negative is gone. And now I know you can reduce 7 and 70. I wouldn't even bother because if you make a mistake reducing it, then you've messed yourself up. Last step. I want to get rid of cosine. So what would I use on each side?
Inverse cosine.
Inverse cosine. And that is the answer for alpha once you type it in. Okay, so let's see what we get. Inverse cosine of 7 divided by negative 70. It doesn't matter if you're like, well, why did you put the negative in the bottom? It doesn't matter if you put the negative in the bottom or the top of a fraction. It's the same thing. Okay, and I get, if you use inverse cosine. So that's another mistake you could make. You think you pressed inverse and you clearly didn't. 95.739. That's alpha. Now, technically you have a row that's complete. You could use law of sines. I'm going to just warn you against it. I would do law of cosines one more time. Do you have to do it 2 more times? No? How come, Colleen? Yeah, once you have 2, you can just subtract from 180. If you have extra time, you could do it a 3rd time, and that way you could find all 3 things totally separate. That means if you make a mistake on one, it wouldn't have an effect on anything else. But if we're going to find beta, and we make a mistake, and then we use it to find gamma, then gamma is going to be wrong as well. Okay, so we'll just try to go very carefully when we find beta. Okay, not to make a mistake. All right, so that formula, I'm not going to write it this time. Let's just try to remember it. B squared equals A squared plus C squared. Okay. B squared is 49. A squared plus C squared. 81 plus 25. If you want to do 81 plus 25 now, go ahead. I'm just going to write it like that. Minus 2, let's see, AC. So minus 2AC. What's 2 times A times C?
18 times 5.
You could think of it as 18 times 5, or you could think of it as 10 times 9, which is 90. So you can change that order to take advantage of a multiple of 10, because multiplication with 10 is easy. So minus 90, cosine beta. Okay. Add the 81 and 25. What's 81 plus 25? 106. Okay. How about Wyatt, my next step?
You're going to subtract 106.
Yep. In fact, I'm not even going to do it. I'm just going to say, okay, I subtracted 106 to the other side. If you want to do it, you can, but it's not really necessary. And next step.
Divide 90.
Divide.
Oh, cosine.
No, you were closer before. Negative 90. So we're just going to divide that by negative 90. Again, I'm not even going to figure out what it is. But the last thing I need to do to get rid of cosine is inverse. So I kind of saved a little time by not doing this calculation out. I do need to type it in now. If you don't want to do it that way, you don't have to. You can do it out at each step. Second, inverse cosine. I want to do the numerator first, because following order of operations, that's how you do it. If that's confusing, do this calculation out separate. Do 49 minus 106 on your calculator, hit divide by negative 90, write that number down, and then plug it in. Okay, just do it in 3 steps instead of 1 like I have. Bless you. But if you want to do it all in 1 step, that's how you do it. Okay, 50.704. Okay, any questions on how we found beta? Hey, now gamma is easy. You could do law of cosines again, or let's just add up what we have and subtract from 180. So we got 95.739 plus 50.704. Okay, 146, and then subtract that from 180. 33.557. Okay, looks like the biggest angle is with the biggest side. Smallest angle, smallest side. Seems like we're on track. Any question on that one? So we're going to skip over the word problem. And we're going to look at area of a triangle. Now, you might be like, well, how does the area of a triangle have anything to do with law of cosines? There's a formula in this section that they prove using law of cosines to find the area of a triangle. That's the connection. We're not going to go through the proof, so you're not really going to see kind of where the law of cosines formula for the area of a triangle is coming from. But first, we'll look at this formula. I think there's two. There's that one, and that's the one that uses law of cosines, which I'm not going to show you a proof of. This one's a little different, which I'll show you. So, hopefully from geometry you remember the area of a triangle is half base times height. Well, that's great as long as you know the height. But what if you don't? What if you don't have the height? Can you still find the area of a triangle? And the answer is yeah, you can. Okay, so let's say we wanted to find the area of this triangle. And let's say they gave you some information, they tell you the base, and then maybe they give you one of the other sides and one of the other angles. But they don't tell you the height. This is the height. We'll call it h. And let's pretend that you don't know it. Okay, well, let's look at it from this perspective. We already know the base. Let's come up with a formula to find the height. Okay. What kind of triangle do I have showing right there? It's a right triangle. So I can use Sakatoa. I have an angle. I want to know that. And they'll tell me that in the problem. H is opposite. A is hypotenuse. What trig function has opposite and hypotenuse in it? Sine. So if you write it down, sine of gamma equals h over a. And now I'm trying to get a formula for h. So I want to get the a on the other side. How would I do that? My way? Multiply by? Yeah, just multiply each side by a. Now you have a formula that calculates the height for you based on some other information. So what are we going to do? We're going to put that right there. And that's going to give you a new formula for the area of a triangle. Area equals 1/2. Let's just call the base B. And now for height, don't put h. Put what h equals in that box. A sine gamma. A sine gamma. So that's 1/2 the base times the calculation for the height. The only thing they normally do with that is they put it in alphabetical order. Doesn't really matter, but that's just how they write it. Okay, now look at this triangle. I want you to look at the two sides in the formula. There's an A and there's a B. And then look at gamma. Where is gamma? Where is this angle in relation to those two sides? It's in between them. In fact, you can write this formula using any two sides you want, as long as you always pick the angle between them. Here's another way to write the same formula. 1/2 BC sine alpha. Okay, check it. 1/2 BC Alpha is the angle between B and C. So in general, you can write it any way you want as long as you follow this pattern. The area of a triangle is half the product of the two sides, any two sides you want, times the sine of the angle between the sides. You've got to use the angle between. So that's how I remember. Half the product of any two sides times the sine of the angle between. And you're really just doing 1/2 base times height. It's just you use a little right triangle trig to calculate the height. And we built it into the formula. Any questions on how we came up with that formula or why that is the formula? Okay, now that we have the formula, we just use it. So the sides here aren't labeled, and they don't have to be. As long as you know two sides and the angle between, you're good to go. Anyone tell me what the calculation would be to find the area of that triangle?
Times sine 105.
Can you say
1/2.
Yep, 1/2. That's good. 1/2 the product of.
12 plus 3.
It doesn't say to add them together. It just says half the product of the two sides. There's no plus sign in that whole formula.
Yeah, so 12.
Yeah, just 12 times 3. So 1/2 the product of the two sides. And what else?
Times sine 105.
Yep. So sine 105. And that's it. Just type that in. To speed things up a little, you could do this out. Half of 12 is 6. 6 times 3, 18. So 18 sine 105. So the area is 17.37. Now area is two-dimensional. We don't know the units. So we'll just call it units squared. Okay. Any questions on how to find the area if you're given two sides and an angle like that? Does anybody want to see another one of that type? No? Okay, so then us type. This is the formula that you can prove using law of cosines. That's the connection. The proof kind of takes a while, so we're not going to do the proof. I'm just going to tell you that this is the formula. That comes from the law of cosines. It's the square root of s times s minus every side. S minus A, S minus B, S minus C. So A, B, and C, we know what those are. Those are the sides. S, we've never seen S before. S is what you call the semi-perimeter. It's half of the perimeter. How do you get perimeter? You add up all the sides. How do you get the semi-perimeter? You take half of it. Okay, so this is just another case of they give you A, they give you B, they give you C. You plug everything into the formula and do it out. Very minimal thinking involved. And that name, that's called Heron's formula. The other formula, these don't really have a name. Okay. Any questions on what I've given you so far about Heron's formula? So now we'll do an example, and then that'll finish 8.2. Most people like the area of a triangle problems on a test because they're really quick, they're easy, and they can kind of bring your grade up if you have trouble with some of the harder stuff like law of sines and cosines. Okay, so let's find the area of that triangle. So they've given us 3 sides. Anytime you're given all the sides, Heron's formula is the way to go. I don't have any angles here, so I don't want to use the first formula that I gave you. I could, if I really wanted to, I could use law of cosines and find one of the angles. We just did that. That was the very first problem we did today. But if you want to speed things up, just use Heron's formula. Let's start with finding the semi-perimeter. Curtis, how do I find the semi-perimeter? Josh?
You do A plus B plus C all multiplied by 1/2.
Formula for the semi-perimeter, exactly what he just said. A plus B plus C, all multiplied by 1/2. Okay, so let's do it out. 1/2, 9 plus 7 plus 5. Okay. PEMDAS, do what's in parentheses first. What's 9 plus 7 plus 5? Did someone say 20, 21? Yep. And half of 21? 10.5. Okay. Any questions on that? Now you have everything you need to find the area. It's S times S minus every side. Doesn't matter what order you do it in. Most people just go right in order. So I put S, now I'm going to do S minus A, S minus B, S minus C. I would do this part out before you type it in. That'll just save a lot of parentheses on the calculator. So I've got 10.5 times, what's 10.5 minus 9? 1.5. 10.5 minus 7. 5. 10.5 minus 5. 5.5. Now type that in. Okay, so the area is, you can type it with parentheses like that, or you could just hit the times symbol. I would just hit the times symbol. It's less buttons. 1.5 times 3.5 times 5.5. So the area of the triangle is 17.41 square units. Okay, if you were measuring in inches, it would be square inches, feet, square feet, and so on. Okay, so any questions on how to find the area of a triangle using those two formulas? Okay. So part of the homework that I'll check the next time we have class is the ones that you didn't do. So 5, 6, and I think you did 18. So if you already did 5, 6, and 18, you're good. You need to do 1, 2, 13, 14, 17, 19. Okay. Does everybody have the homework from 8.2? Okay, so we're going to start to take a look at 8.3. 8.3 is, I'd say, the same difficulty as the last two sections. It's relatively straightforward. 8.4 is a little tougher. Okay, so for this week, 8.4 is probably the toughest one. But we're not dealing with that today. All right. So what 8.3 does is it's totally separate. So I want you to forget about solving triangles, forget about finding the area of a triangle. Triangles are done. Okay. 8.3 basically gives us some ways to do arithmetic with complex numbers using a shortcut. Okay. So when we dealt with complex numbers before, we might have had to do things like this. And you would have had to like FOIL that all out. Well, we can get rid of all that. We can make it so we don't have to FOIL it, and we can do things in a much shorter way. Okay, and we might have looked at a couple of these shortcuts. I think we did that shortcut back a while ago, but I'm going to show you a couple other shortcuts. Okay. Remember that this is how you normally write an imaginary number. So you could have something like, you sign in for me, 2 plus 3i. In that number, 2 is the real part, 3 is considered the imaginary part. Basic algebra 2 stuff. Well, what we can do is we can graph that number. Okay? Graphing a complex number is super easy. If you can graph the coordinate 2, 3, you can graph 2 plus 3i. It's actually exactly the same thing. Okay? So I'm going to show you how to graph a complex number. Okay? Written just like that. Graphing a plus bi is just like graphing a comma b. It's exactly the same thing. So because there's two numbers, you have to graph it on a plane. Okay, number line is good when you have to graph a single number, but for coordinate, you've got two numbers. So you need an x and a y-axis. Well, x and y-axis is what you call it in Algebra 1, okay, when you're graphing a coordinate. We have a real part and an imaginary part. So when we graph complex numbers, you're going to call the real axis the horizontal. That's why real comes first. And you're going to call the imaginary axis, which is normally y. You're going to call the y-axis the imaginary axis. Okay, so that's the complex plane. If you have a positive real number, you go right. A negative real number, you go left. Positive imaginary is up. A negative imaginary, down. The direction is exactly the same as what you're used to. Okay, so I'll give you a few examples and we'll just graph them and see what we can do. Okay, does everybody have that sketch? Real and imaginary? All right. So let's try to graph this. Okay, -4 minus 2i. Starting at the origin, can anybody tell me what direction would I go to graph -4 minus 2i? Go left how many? 4. Left 4, because this is the real. It's the imaginary. So left 4 and then down 2. That's it. Left 4, down 2. That's how you graph the point -4 minus 2i. How about -2 plus 3i? Colin?
So left 2 up 3.
Yeah, left 2, up 3. This kind of stuff, I think, is really, really straightforward. How about 5i? It's like 0, comma 5, right? You just go up 5 on the imaginary. And 6. Yep.
You just go to the right
You
six.
just go to the right 6. That's like 6, comma 0. Okay, any questions on graphing complex numbers? Okay. I think the next is absolute value. Yes, absolute value. What does absolute value mean? It's the distance from 0. Well, we can find the absolute value of a complex number just like any other number. 0 is right there. What do we call that point that I just marked? In 2D, it's not really called 0. It's called the origin. So you want to find an absolute value of a complex number. It's the same definition you've always used. It's the distance to 0. The absolute value of that would be that distance right there if you could measure it. Well, you can measure it. Very easy. Make a triangle out of it. That side's 2. That side's 3. And how would you find the hypotenuse? Colin?
Pythagorean. I can never say it, but theorem.
I know what you
A plus the a squared plus b squared equals c squared.
Pythagorean. That's okay.
Yeah, I just can't say that word.
So Pythagorean theorem is how you find the hypotenuse, and that's how you find the absolute value of a complex number. So this is your coordinate that you graph. A is the real, B is the imaginary. To find the absolute value of A plus BI, you're just doing the Pythagorean theorem. Square A, square B, add them up, and take the square root. If you forget it, really, just remember it's Pythagorean theorem. Make a triangle out of it, find the base, find the height, use Pythagorean theorem. Okay. Does everyone have the formula for absolute value of a complex number? Try an example. So take a second on your own and see if you can find the absolute value of 3 plus 4i. Okay, in that problem, A is 3, B is 4. Just plug it in. Okay, so can somebody just set up my formula for me? You don't have to tell me the answer yet. Just tell me how you set it up. Yep.
Copy the square root of 3 squared plus 4 squared.
Yep. And again, if you kind of forget, what's going on, write 3 up 4. That's the absolute value. It's the distance to 0. Make a triangle. 3, 4, find the hypotenuse. And Colin, did you get an answer when you did that?
5.
5, yeah. This is a 3, 4, 5 right triangle, and that's the absolute value of 3 plus 4i. 5. Okay, that's how you find the absolute value of a complex number. Any question on that? Okay. Sometimes it might not come out nice. Like if it was a 5 and a 6. You'd have 5 squared plus 6 squared. You're probably not going to be able to take the square root when you add that up. Just leave it. You don't have to write it as a decimal unless they ask. All right, so last thing we'll look at, we'll see if we do the example of this today. I'm not sure. At least if you have it written down, then we don't have to write it again later on. So the way we've been writing complex numbers, 3 plus 4i, 3 plus 2i, 4 minus 8i, that's fine. Okay, that's called standard form. Okay, so standard form, again, it's okay, but some things take a long time to do in standard form. So I'm going to show you trig form. So what I've drawn here is same kind of diagram we've been drawing all along when you find absolute value. That would be your coordinate, you would graph it. X is the real part. I called it X instead of A because a lot of times when you see something on a graph, most people are used to X being horizontal and Y being the vertical. They're not used to A and B. Okay? So that's why I called it X and Y. So if you're wondering, where did the A and the B go here? We're drawing it. So now I'm using letters that kind of jog your memory. Horizontal, vertical. Okay, and R, I've just labeled that as the distance from this point to the origin. It's the dotted line that's on a diagonal. Now, all we have to do to write it in trig form, to figure out what the formula is going to be, is find a formula for X and find a formula for Y. Because in trig form, we don't move left and right and up and down, okay, like we graphed before. We have two things in trig form. You have an R and a theta. So the last thing we're going to do is turn X and Y into R and theta. Okay, I'm going to show you how. So, using theta, let's do X first. So I've circled three things. What is the name of the side that I've labeled as X? Is it opposite theta, adjacent, or the hypotenuse? Kelvin?
Opposite there. Or no, the, what'd you say?
Is it opposite, adjacent, or hypotenuse?
It's opposite.
No,
No, it's
adjacent.
Okay.
X is adjacent to theta because it's right next to it. What about R? It's the hypotenuse. Adjacent and hypotenuse. What function has those two things in it? Cosine. So we're going to write down cosine equals adjacent over hypotenuse. Now I want to get X by itself. So what would I multiply each side by to do that? R. Multiply both sides by R. Times R, times R. Now you get R cosine theta equals X. Hang on to that for 1 second. We'll come right back to it. Okay. I'm going to do the same thing again. This time, instead of X, I'm going to use theta, Y, and R. We already know R is the hypotenuse. What's Y? Opposite or adjacent? It's opposite. What trig function involves opposite and hypotenuse? Sine. So I'm going to write down sine of theta equals opposite over hypotenuse. I'm going to do the same thing again. I want to get Y by itself. So multiply by R. Times R, times R. And I get R sine theta equals Y. Okay, so far we haven't done anything really earth-shattering. We've done right triangle trig, which we learned a couple months ago. Any questions on what I just did with these two boxes? Okay, the first box in black equals x. The second box in red equals y. Plug in the first box for x. Plug in the second box for y. And that will give you how you write a complex number in trig form. Okay, so let's just write it out. So if you write it, instead of x and y, you have x becomes r cosine theta. Try to show you everything here. I just stays right where it is. The I doesn't do anything. And the y turns into r sine theta. Now, if you look at the first part and the second part, what letter do they both have in common? R. So instead of writing the R twice, we can just write the R once. Factor it out. That is how you write a complex number in trig form. So as an example of what a final answer would look like, 3 cosine, I'm just going to make up an angle, 15 plus I sine 15. That's a final answer. You don't do anything with it. You leave it exactly like that. Okay, so to use that formula, you need to know two things. R and theta. Well, what's R? I tried to show you in this picture. R is the distance from the point to the origin. It's like the absolute value. That's what R is. It's the distance from the origin. It's the absolute value. You already know how to find that. Theta is the angle right there. It's the angle with the positive x-axis. Using right triangle trig, you should know how to find theta. If not, I'll talk about it next time, but if you know tangent or inverse tangent, you should be able to figure that out. But we'll talk about how to find theta next time. Okay, so for now, just make sure you get what's in that black box, because that's very important. Okay, any questions on that? Okay, so 8.2 and 8.3, very different sections. 8.1 and 8.2, kind of the same thing. 8.2 and 8.3, no. 8.3 and 8.4 are kind of the same thing. So it's kind of like the first half of the week is the same, and the last half of the week is the same. Okay, so we'll pick up with this next time. All right, so for 8.3, you should be able to do 1 through 3. That's a review on complex numbers. 5, 8, I think up to number 12. Stop at 12.
So what's the homework? You've given us like 3 different things.
I've given you 2 things.
So what
I've
is
given you that, and I gave you the one right before I started this section. It's all in the video for your viewing pleasure. Okay, as a reminder, if we don't have class on one day, we might probably have a test on Friday. If we don't have class 2 days, I'll do a take-home due Monday. Okay.